This video is about how bones grow longer. We're looking at a diagram of a very young bone where we can see bone development has started to occur in the diaphysis, and where calcium first starts to be deposited, that's known as the primary ossification center. I indicated that in a star. And what happens during development is that bone growth will continue from the center of the diaphysis towards the epiphyses. And so all of this area is bone, and we can see the medullary cavity that's forming inside of bone. And then right around the time of birth, bone will also start to develop within an epiphysis or both epiphyses. And once bone starts to develop there, also just like a ripple in a pond, it starts to radiate out from there. And so we can see that bone has developed in both epiphyses, and that's known as the secondary ossification center. The rest of the material that this bone is made out of is cartilage. So in other words, all of this tissue is hyaline cartilage, and the same thing here. So all of this is hyaline cartilage, and the bone is starting to grow within the hyaline cartilage. So hyaline cartilage is found in two areas of a long bone. There's the hyaline cartilage that caps the end of the bone. That's known as articular cartilage. And then there's cartilage that's in between the epiphysis and the diaphysis. And in this young bone, we can see there's a lot of cartilage there. That's known as the epiphyseal plate. That's the region where bone is going to grow longer. Let's take a closer look at the epiphyseal plate. So in this picture, what they're doing is they're taking the epiphyseal plate and they're just taking a closer look at it. And so this region would be what we call the epiphyseal plate in between the two lines. The rest of this cartilage that still remains, we would call this articular cartilage. Okay, but here's the epiphyseal plate, and there are two regions of the epiphyseal plate that I want to show you. The region that's closer to the diaphysis, that's known as the proximal face. And then the region that's closer to the epiphysis, that's known as the distal face. What's happening at the proximal face and the distal face of the epiphyseal plate is different, which is why I want to make that distinction. So let's see if we can make sense of this picture. Here is the epiphyseal plate. I'll outline that in blue again, and those little bubbly looking structures inside of the cartilage are cartilage cells. And I notice how the cartilage cells are bigger at the proximal face. That's known as hypertrophy. What that means is that this cartilage matrix is starting to become ossified. And the reason that it's becoming ossified is because, recall, in the diaphysis, these would be osteoblasts, and they're secreting osteoid. And so in other words, what's happening in the diaphysis is bone formation is occurring, and that bone is starting to invade the proximal face of the epiphyseal plate. And as it invades the proximal face and get some calcium depositing in here, it starts to kill off the cartilage. And so in other words, bone growth is going to start to invade the proximal face of the epiphyseal plate. At the same time that that's happening, the cartilage cells at the distal end of the epiphyseal plate are in a rapid state of mitosis, and so they're growing. So what you have here is a dynamic where bone formation is invading at the proximal face, but cartilage growth is occurring at the distal face. And so when we take a look at this picture, what we see is bone growth went up to here at time 1, but now I see bone has invaded more. Okay, so they're showing me there's a certain amount of bone growth there. Same thing with cartilage growth. If we take a look at that it looks like the cartilage is ending right about there at time 1. But at this picture, this is a lapse of time. At time 2, the cartilage grew quite a bit, and now the cartilage goes to here. And so what we want to notice here is that as long as the bone growth is equal to the cartilage growth, then the cartilage will keep outrunning the invasion of the bone, so to speak. And what's happening is the epiphysis, the end of the bone out here, keeps getting pushed out further, and that's how the bone grows longer. That's what they're showing us in this picture, where they're dividing the bone in half, and they're trying to show us that bone growth is invading at the proximal face of the epiphyseal plate, but at the distal face, the cartilage keeps growing. And so as long as cartilage growth and bone growth occur at the same rate, what happens is that epiphyseal plate gets bumped out further and the bone grows longer. Eventually, what's going to happen is hormones at the time of puberty, growth hormone, sex hormones stimulate bone growth, and so bone starts to grow more rapidly. It rapidly invades the epiphyseal plate, more rapid than it was before, and at the same time, the cartilage growth starts to slow down. And so because we're not getting equal cartilage growth, what will happen eventually is the bone is going to catch up to the cartilage, and once the bone invades and catches up to the cartilage, what it will do is it will just leave a thin remnant of cartilage, and that's known as the epiphyseal line. And so the epiphyseal line is what the epiphyseal plate was. It's a remnant of the epiphyseal plate. So the epiphyseal plate we see in young bones that are still growing, and the epiphyseal line we see in mature bones that don't have the potential to grow longer. So we can see that in x-rays too. The white arrows are pointing to the epiphyseal plate. Notice that the cartilage on an x-ray is just appearing transparent, and so the epiphysis looks separate from the actual bone. Notice here's the diaphysis, here's the epiphysis, and so the epiphyseal plate is an indicator that this bone is still growing. Compare that to this picture. This picture, the white lines are showing us the epiphyseal lines, and so to look at that same comparison here, we don't see that there's a gap of cartilage. Instead, we see that the epiphysis and the diaphysis have grown together, and that bright white area is known as the epiphyseal line.